So today we are going to see the heat exchanger. As the name is, the same function it is going to do. Okay, that means it is going to exchange the heat between the two different fluids. Okay, let's say we are having two fluids, a hot fluid and another one is a cold fluid. Okay, and we are allowing it to flow through a particular channel, different channel. Okay, they are separated by certain media. Okay, so what will happen, there will be a transfer of heat from hot body to the cold body. Okay, so whatever this device is, that type of device is known as a heat exchanger. Okay, then heat exchanger, they are used for both cooling as well as heating purpose. For example, let's say uh, pasteurization process. You can take a pasteurization process in the milk industry. What is the pasteurization process? That means you are heating the milk suddenly within a short period of time to around 80 to 90 degrees Celsius. Okay, so in that case, that means heating process is there. For that purpose, a heat exchangers are used. Similarly, after pasteurization, or you can say after heating it to the very high temperature in a shorter period of time, again it is cooled down to around 4 to 5 degrees Celsius again in a shorter period of time. So again the cooling process is there. So for both the process, what you can see here, that heat exchangers are used. Okay, the fluids may be separated by solid walls to prevent a mixing, or they may be directly in a contact. This may happen that like I said, just I have just given you the example of a milk industry. In that, milk doesn't has to be should not mix with any other fluid, right? Otherwise it will get contaminated. So in that case, it is separated by a solid wall. Okay, that can be mostly it is a stainless steel pipes are there. Okay, or tubes are there. Okay, while let's say if you want to cool a water, so what you can do, you can add another you can add the cool water. Okay, cold water in the hotter water. So in that way, what is going to happen, there will be a mixing, and what will happen, certainly there will be a transfer of heat also. Okay, so there can be a direct contact or can be a indirect contact, or you can say it is separated by the solid wall. Okay, then next is, they are widely used in space heating, okay, refrigeration, air conditioning, power station, chemical plants, petrochemical plants, petroleum refineries, natural gas processing, and sewage treatment plants. Okay, beyond this also there are a number of applications for the heat exchangers. What is going to happen, because wherever the cooling or heating or transfer of heat is required, so in that case always the heat exchangers are suggested. So now heat exchanger, they are of mainly of three types: parallel flow, counter flow, and cross flow. Okay, these are based on the direction of the flow, how the two different fluids are going to flow, their directions. So you can see this is the first one, that is the parallel flow type of the heat exchanger. Now here you can see what is there. This is the tube. Okay, outside tube is there. Yeah, this is the cross section. Okay, this is the cross section. Okay, longitudinal section. You can say longitudinal section is there. So there is a tube, and inside that there is another tube. Outside tube, let's say it from that fluid, a cold fluid is going to flow, and in the inner tube, from the inner tube, hot fluid is going to flow. If the direction of the colder fluid and the hotter fluid, they are same and parallel to each other. Okay, the direction of the flow of hotter fluid and the colder fluid, if the direction and they are parallel to each other, so that type of flow or that type of heat exchanger is known as a parallel flow heat exchanger. Okay, then next one is this one, that is the counter flow heat exchanger. That means you can see it, the direction is they are parallel to each other. Hotter fluid and colder fluid, they are parallel to each other, but the directions are different. Hotter fluid is going in one direction, and exactly in opposite direction the colder fluid is moving. Okay, so that type of heat exchanger is known as a counter flow heat exchanger. Okay, then next one is this one, as a cross flow. So you can see exactly perpendicular direction is there. One fluid is going in this direction, let's say. So the other fluid will be going in the perpendicular direction exactly. Okay. So these are the basic what you can say a type of the heat exchanger based on the direction of the flow. Now, why see the construction for this parallel flow is quite easier. Okay, easy to what you can say give the direction. But here what you can see, when you are using the parallel flow heat exchanger, let's say if we plot a graph of temperature difference, okay, or temperature of the fluid versus the length, okay, length of this heat exchanger. So what you will observe, let's say here the temperature of the colder fluid is TCI. So you can see this is the TCI, colder fluid. Okay, so definitely as it is the colder one, okay, so it is denoted by TC, and inlet, that's why I. And here the hotter fluid is denoted by its inlet is denoted by THI. So on this line or on this side, you can see TCI is the inlet temperature of the colder fluid, and THI is the hotter fluid inlet. Okay. Now, when it is moving in this heat exchanger over a period of this length, what is going to happen? Over this length, along this length, what is going to happen? The heat is going to exchange between this hotter fluid and the colder fluid, right? Correct. Okay. So what is going to happen? The colder fluid is going to slowly increase, okay, its temperature. Its temperature is going to increase slowly, slowly, slowly. Similarly, the hotter fluid is going to lose its heat towards the colder fluid, and you can see there will be a decrease in the temperature slowly, slowly. Okay. So here you will observe that in any heat exchanger, there will be an increase in the colder fluid temperature and decrease in the hotter fluid temperature. Okay, but after a certain time, there will not be any exchange. Even if you increase it further, there will not be any exchange. Why? Because each this
Balanced.
yeah, it will remain constant. But why? Because what
They
will
will get
happen?
balanced.
Yes,
With
And thermal equilibrium will be attained.
thermal equilibrium, when you can say it as a thermal equilibrium, when the temperature is same. What I am saying, after a certain period of time, there will be no decrease in the temperatures or increase in the temperature. This delta will remain same. Delta T will remain same. Why? Because it is surrounded by certain tube, as that tube is having its own thermal conductivity. It will not conduct it beyond that. Okay, so accordingly, we have to design the length also. Okay, then this is what is about the parallel flow. Now, why we have moved toward this counter flow? This is the advanced one than this one. Okay, because with the same length, we can get more change in the temperature, more and more change in the temperature. As we know, we can see here that from TCI it has gone to the TCO. Okay, and here from THI it has gone towards the THO. Okay, but now when the counter flow arrangement is there, that means on this side, on this left side, there will be a inlet to hotter fluid. This is the inlet to the hotter fluid, and outlet of the colder fluid is there. Okay, while on this side there is a outlet of the hotter fluid and inlet of the colder fluid. So when you are arranging this counter flow arrangement, you will find that over a period of length, okay, over this length, what is going to happen? The delta T is going to continuously remain same, almost remain same. Here it is going to change. Okay, and we know that by the law of the conduction, okay, or the law of convection or conduction even also, okay, that heat transfer rate is directly proportional to delta T, right? delta t जितना ज्यादा रहेगा उतना ज्यादा heat transfer rate रहेगा. So you can find here initially the delta is very bigger one. So initially you can see from the graph itself that the heat exchange is more. Okay, that means heat transfer is more. But when the delta T is reducing, after that what is going to happen? The heat transfer rate is reduced. Okay, it is reduced. Rate is reduced. Okay, there will be a heat transfer, but the rate will be reduced. That means you will not get a very difference in the temperature. ज़्यादा कोई difference आपको मिलेगा नहीं, even अगर आप उसको थोड़ा और बढ़ा देते हो. Okay, so that is what is going to happen in this parallel flow. While in the counter flow, you will find here that delta T is almost remaining same. That means when you are increasing the length, you will still get very quite good amount of the change in the temperatures. Okay, so that's why this is suggested. Basically, counter flow is suggested to reduce the size. Okay, इसके लिए जितना लेंथ लगेगा उससे almost काफी कम लेंथ आपको यहाँ पर मिलेगा. So you can see here, see TCI is same, THI is also same. Okay, and what is going to happen? The heat is going to exchange in between it, but you can see it has reached from TCI to TCO. Here you can see TCO is at this level. So आप इतना difference देख सकते हो. You can see this much difference has been achieved for the colder temperature. Similarly, for the hotter temperature also, यहाँ पर आपका hotter temperature आ रहा है TCO यहाँ पर पिछला वाला. Okay, parallel flow का. While in the counter flow, it has reached to up to this level. So you can find there will be a significant change in the temperature. okay, with a shorter distance or with a same distance, okay, बहुत ज़्यादा difference आपको मिल जाएगा, okay. So in this type of flow or the arrangement, you will get more and more heat transfer rate over a period of length, okay. Now there is another type, that is the cross flow. Now cross flow ना इसके तरह भी करता है ना इसकी तरह भी करता है, but why this is used basically, let me give you an example. Have you seen the radiator of any truck? Have you seen the radiator of the truck? हाँ तो हाँ बोलो, नहीं तो नहीं बोलो, no issue.
No, ma'am.
No, ma'am.
Okay, so let me show you a figure of it so you will understand it much better. मुझे आपको दिखाऊंगी तो आपको ध्यान में आ जाएगा कि कैसे है करके, क्या है करके, ठीक है. Okay, so this is the truck. So this part, okay, you will find that it is open, and if you let's say this truck is running and after that it stops somewhere, and if you stand in front of it, you will feel a heat. Okay, that heat is basically due to the radiator.
Yes,
Okay,
ma'am, that's
so
Yes, yes.
yeah, so this is basically a radiator part. ये बाहर का covering है. Inside I will show you again. Okay. So inside it is looking like this, okay. Now what basically radiator is, see, every engine, it is going to lose some amount of the heat, and that amount of the heat will be lost in the atmosphere, okay, or it will be carried by the material of that engine, okay. So if continuously that material is going to accept that heat, after certain period of time, that those material or those different parts, they may get damaged, okay. So to avoid that, cooling has to be there. So a coolant, okay, a coolant, it is actually circulated through the channel of that engine. I will show you soon in the previous sorry, in next coming slides, that how that cooling takes place basically, or where those channels are, okay. So what happens, the surrounding the engine a small channels are provided, and through which the coolant will pass. Though that coolant will take the heat from the engine, okay. Now that coolant is heated one, so now you are supposed to cool that coolant again. So that coolant will pass through this radiator, okay, and this radiator or this coolant is then cooled by the surrounding air, okay. When just a minute. So when this vehicle is going to move, what will happen? The air will flow over this. That means that air will carry the heat from that coolant, okay, and that heated air will be thrown outside from the back side again. यहाँ से नीचे से gap होती है, okay. So from there it will be thrown outside. So continuously that the atmospheric air is coming over that radiator, cooling that coolant and sent outside. And accordingly, what will happen? The coolant will get cooled, and then that cooled coolant will be again sent back to the engine to carry the heat from that. Okay, so this is how basically the radiator is operating. So you can see here what is going to happen. So you can see here, this is the direction for the coolant, okay, that is parallel to this one, and air is going to perpendicularly flow over it, okay. That means it is a cross flow, okay. So it is again a heat exchanger, and the flow is a cross flow. इसमें हम लोग side flow या parallel flow ऐसा कुछ नहीं कर सकते, not possible, because air is going to flow in front of it, okay. So that's why this is the cross flow type of the radiator, okay. ज्यादा जो effectiveness है आपको उसी वक्त मिलेगा when it is going to be cross flow. अगर पैरेलली करोगे तो क्या होगा, this will come in front of it, so this may happen कि that most of the air will get lost, okay. So your air will flow from the sides, and almost very 50%, less than 50% the effectiveness will be there for this if the flow will be parallel to the channel, okay. So that's why it is suggested always for the radiator the flow should be cross, okay. Any doubt till this?
No, ma'am.
Okay, so this is what about the heat exchanger is, okay. Now let's move to the next part, that is the IC engine, study of IC engine. Can anybody please tell me what is meant by IC engine? IC means what? Hopefully you have heard
Integrated
something.
circuit.
No, we are not talking about circuit. We are talking about the engine now.
Ma'am, internal combustion.
Correct. Very good. Internal combustion engine. So see here, we have studied the thermal power plants, right? Uh, in the unit number 1, and in that we have seen the gas turbine also, right? Let me show you the figure for that, so you understand it much better. Okay, so hopefully you remember this diagram. Okay, so what is going to
Yes.
happen here? Here, the power is going to develop inside the turbine. Okay, inside the turbine, but the combustion is going to take place outside it. Combustion is going to take place outside it. So that's why this type of engine, or this type of the system, it is known as a external combustion engine, where the combustion is taking place outside the engine. This is your engine where your power is getting developed. Okay, but the combustion process is going to take place outside the engine. That's why it is known as a external combustion engine. Okay, now if the combustion is going to take place inside the engine, okay, where the power is also going to produce, so that type of engine is known as the IC engine, or internal combustion engine. Okay, so I think before going to the classification, let me show you the different parts, so you will understand it much better again. Okay. Okay, so you can see this is the internal combustion engine, one of the type of the internal combustion engine. Okay, so in that, what is going to happen? What are the different parts? First, let's understand that. Okay, this is the cylinder. Okay, in which this piston is there, which is going to reciprocate up and down. The piston is connected to this connecting rod, which is connected to this crankshaft. So crankshaft is going to rotate. This piston is going to reciprocate. Connecting rod is going to oscillate, and as it is connected to this crank, you will get the rotation motion on this crank. Okay. Uh, um, Beyond this, you will see this green part. Okay, so this is the intake manifold. That means a part or the passage for intake of the charge means what? It can be a air fuel mixture or can be only air. Okay, it depends on the which type of engine is there. Okay, then this is the exhaust manifold. That means whatever the burnt gases are, that will be sent outside through this passage. This is the inlet valve, which will be open only when the suction is going on. Otherwise, this will be kept closed. This is the exhaust valve, which will be kept open only when the exhaust is going on. Okay. After that, you can see a spark plug is provided over here. Okay. If it is a petrol engine, a spark plug is provided. If it is a diesel engine, instead of it, fuel injector is provided. Okay. So these are basically basic parts of the
What is
engine.
difference between
Okay.
them?
Yes.
What is difference between them?
What is difference between what?
Spark plug and that diesel one.
Yes, I will let you know soon. Okay, I will let you know soon. We are going to study that in detail again. Okay, so these are the basic part which are required for you for. Okay, Yes, gudging pin, it is simply the joining part for the piston and the connecting rod. Similarly, crank pin is there, which is helping you to join the connecting rod and the crankshaft. Okay. Now, as I said about the cooling jacket, okay, or the passage which through which the coolant is going to pass. So this you can see the green part in this diagram. Okay. So this is the passage to pass the coolant, okay, which carries the heat from this whole cylinder, okay, and passes it towards the radiator to lose the heat into the atmosphere. Okay, so these are the basic parts of any internal combustion engine. Okay, now internal combustion engine are classified by certain categories, okay, based on the certain categories. So you can see here, first is based on number of stroke per cycle. Okay, number of stroke per cycle, I think we should skip the classification for now. First, let's understand four stroke, two stroke, and then we will move to the this classification. It will be much better. Okay, so let's understand first that what is meant by four stroke cycle engine and two stroke cycle engine. Okay, so these are the very basic types of the any internal combustion engine. Okay, that is four stroke cycle engine and two stroke cycle engine. Now first let's understand what is meant by stroke. Okay, stroke means what? See, this is the piston. Okay, the piston is going to move up and down. The maximum limit of the piston, okay, that limit is known as the top side, on the top side it is known as the TDC, top dead center. I think we have covered this in the practical session also. Okay, so the maximum upper distance or upper level this piston can get, that is the TDC, or known as the top dead center. Similarly, the bottom side, okay, the max or the last limit on the bottom side for this piston is known as the bottom dead center, or BDC. That distance between that TDC and BDC, that is known as a stroke. One stroke, it is known as a one stroke. Okay, so when the piston is going to move up and down, that means four stroke will be there. Once up, then second again down, third time up, and fourth time again down. Okay, when it is going to move four times up and down, okay, while one cycle is going on inside this cylinder. One cycle means what? Inside that this four processes are going on: induction or intake, okay, or suction, it is also known as suction, okay, compression, then power, and exhaust process. All these four processes are going on, and while these four processes are going on, the piston will move four times up and down. Okay, two times up, two times down. Okay, so that's why it is known as the four stroke. Now another one is a two stroke. Now two stroke, again the same processes are there. Okay, that is suction, compression, power stroke, and the last one is the exhaust. But for the whole cycle, or for all these four processes, the piston is going to move only twice. Okay, up and down only twice, once up and once down. So that's why it is known as a two stroke engine. Okay, any doubt in this till now? Why four stroke and what is two stroke?
No, no, ma'am.
Can you
Yes.
repeat, please?
No, ma'am.
Should I
And
repeat once
stroke,
again?
Yes.
yes, ma'am. Stroke से repeat करो.
Yes,
समझ
ma'am.
में
Yes,
आता है.
ma'am.
चलो.
Okay, okay, no problem, no problem, no problem. Let me show you another diagram so आपको stroke समझ में आ जाएगा. Okay.
मतलब मैम पिस्टन का ऊपर नीचे होना उसको स्ट्रोक बोलते हैं.
हाँ, एक पूरा एक बार जो डिस्टेंस वो ट्रैवल करेगा,
हाँ.
उसको बोलते हैं स्ट्रोक.
ओके.
दिखाती हूँ आपको एक डायग्राम प्रॉपर दिखाती हूँ, so you will understand it much better. Okay. Okay, can you see this diagram? See, this is the piston. Okay, the piston is definitely going to move up and down. Okay, and it is going to have certain limitation beyond which it will not move further. Okay, so वो जितना ज्यादा ऊपर जा सकता है उसका मैक्सिमम जो लेवल है दैट इज द टीडीसी, टॉप डेड सेंटर. सिमिलरली जितना ज्यादा नीचे जा सकता है उसका मैक्सिमम लिमिट है नीचे जाने का बीडीसी, दैट इज बॉटम डेड सेंटर, एंड द डिस्टेंस बिटवीन दैट इज नोन एज द स्ट्रोक. Okay, distance between that is known as the stroke. Matlab, once it will move in upward direction, that will be known as a one stroke. When it will move in a downward direction up to this BDC, that will be second stroke. Again, it is going to move in a upward direction, that will be third stroke. And when it's going to move in the downward direction, that will be fourth stroke. Four stroke. Okay, are you getting this? That means 4 times it is moving up
Yes,
and
ma'am.
down. 2 times up,
Means
2
the
times
distance
down.
between TDC and BDC is stroke.
Correct. Yes,
Yes.
distance between that is known as the stroke. And when it is going to cover 4 times or 4 strokes are there, at that during this whole 4 stroke, if the all these four processes are going to carried out, okay, that is this suction or induction, compression, power, and exhaust, then it is known as a 4-stroke engine. Okay, because for all these 4 processes, it needs 4 strokes. Okay, and for all these 4 processes, if it needs 2 strokes only, then it is a 2-stroke engine. Understood?
Yes, ma'am.
Ma'am, but
Okay.
Yes, ma'am.
how is the cycle completed? Because in first diagram it is at TDC and in last diagram is at BDC. So, but cycle is not completed, no?
Yeah, it will complete. Okay, I'll explain to you when we will see the working of it. Okay, for now, did you understood about what is 2-stroke engine and 4-stroke engine?
Yes, ma'am.
What is difference between that? Did you understood? Okay, good. Okay, now let's move to the working of it. So what is going to happen now? Let's say your engine is closed. Okay, it is not working. Okay, it is stopped. And when it is stopped, what you will do first? You have to give certain motion to this piston. Okay, now how the piston will move? For that, you are supposed to move it manually. That means when you are working on your vehicle, okay, how you are going to start it? There are 2 different methods. Okay, one is by button start and another is by
And kick.
kick. Yeah. So when you are giving the kick, basically you are rotating this crankshaft. Okay, you are giving the motion to the crankshaft. That means what will happen when this will rotate, this will start oscillate and there will be a motion in the piston. That means piston will move up and down. So initial motion will be given manually. Okay, one is by kick and other is by kick. Button start. Button start means what you are doing basically, you are giving the power to the starter motor. Again, starter motor is connected to this crankshaft. That means initial motion will be given to the crankshaft and then your piston will move up and down. Okay, so this is how basically your engine will start. Now, initial motion has been given already, but after that, are you kicking it again and again? No. Then how basically the piston is going to move? Okay, piston is basically moving because of this combustion process over here. Okay, now for that, let's understand first from here. Okay, when you have given the motion to the piston will start moving up and down. That means what will happen when initially it is at the top level. Okay, and inside this top or you can say above this piston, there is nothing, only the air is there. Okay, and that air is also very small volume is there. Okay, so when the piston is going to move downward, initially this wall, this is the inlet wall and this is the exhaust wall. Initially the wall is also closed because it is not in a working condition, right? So what will happen, initially the piston will move downward and whatever the air inside it, its volume is increasing. That means the pressure will start decreasing. Okay, when the pressure will start decreasing, that means what will happen, this wall will get pushed down, suction will be created and a fresh charge will be taken inside. Okay, fresh charge will be taken inside. That means in case of petrol engine, air and fuel mixture will be taken inside. Now why, I will let you know again soon when we are going to study the carburetor and the direct injection system. Okay, for now keep in mind that when the petrol engine is there, air and fuel mixture will be taken inside. Okay, then that means what will happen when the piston is going to move downward, volume is increasing, pressure is decreasing. Due to that, the suction valve will get pulled down, okay, and the fresh charge, that is air and fuel mixture, will be taken inside. Okay, so this is known as a suction process. Okay, after that, when it has reached to this bottom dead center, नीचे जब आ जाएगा, after that again it will start moving upward. Okay, due to inertia, it will again start moving upward. When it is moving upward, now you have already took the charge inside it. That means it is already filled with certain fluid. Okay, air and fuel mixture. Now, when the piston is moving upward, what will happen? The pressure will slowly rising up. Due to that, this valve will get closed. Okay, this valve will get closed, but the pressure is still going to increase here to certain limit. Okay, so when the pressure will increase over here, and at the end of the compression, okay, मतलब पूरा top dead center पे पहुंचने से थोड़ा सा just पहले, what will happen? The spark plug will induce a current in it. Sparking it will throw. Okay, and when it will spark, it will provide a spark to this charge. What will happen? The combustion process will get initiated, and the whole air fuel mixture will get burn over here. Okay, and huge explosion with a very high pressure will be developed. Okay, and due to the very high pressure, the piston now is going to move downward. Okay, it will be forced to move downward. That means the power is going to produce at this place. Okay, when the combustion is going to take place, a huge amount of pressure will develop, and it will push this piston downward. That means a power will be it will be developed on this crankshaft. Okay, now crankshaft is moving due to the explosion, not due to the kick or the button start. It is moving due to this explosion. Okay, but now when it has reached to the bottom dead center, okay, that means what will happen? Everything is now burned over here, but that burnt gases has to be thrown outside. Otherwise, how you can take the fresh charge again? So that's why the piston now moving upward due to the inertia. Okay, and whatever the burnt gases are, they will be thrown outside through this exhaust manifold. Okay, and at that time, this exhaust valve will be open. Okay, and that that exhaust or the burnt gases will be thrown outside. Okay, now when the piston will move, it will reach to the top dead center. Again, now the volume is less, and inside it only very few burnt gases will be available. But again, the piston is going to move downward. Okay, the piston is going to move downward, and then volume will again increases, pressure will decreases, and again the fresh charge will be taken inside. That means suction is going to take place, and the cycle will repeat once again. Okay, so this is going to happen. This is what is going to happen in the 4-stroke petrol engine. Did you understood this? 4-stroke petrol engine. Okay,
Yes,
now here
ma'am.
you can see only, yes.
नहीं समझा मतलब.
Okay, now here you will observe that only the power is going to develop in one of the process, and just due to that, whatever the power has been developed, okay, remaining motion of this piston, okay, remaining motion of the piston, that up and down motion of the piston, it is due to the inertia. Okay, we are not providing any power to this piston in this remaining 3 processes so that it can move up and down, but just due to the inertia, it is going to move up and down, and power is going to develop only in this 3rd process. Okay, power process. Okay, so this is what is going to happen in the 4-stroke petrol engine. Okay, now let's talk about the diesel engine. Okay, in the diesel engine, there is no spark plug at all. Instead of spark plug, there is a solid injector. Okay, or a fuel injector is there, which is having a very small nozzle. Okay, एकदम छोटा सा nozzle लगाया हुआ होता है. Okay, now what is going to happen in the diesel engine? The same process is going to happen. Okay, piston is going to move downward, volume is going to increase, that means pressure is going to decrease, but here instead of air and fuel mixture, only air will be taken inside. Okay, only air is going to taken inside. Okay, and after that, when the piston will reach to the bottom dead center, the suction valve will get closed, and the piston will start moving upward. When it is moving upward, the air will get pressurized. Okay, the air will get pressurized, and when it will reach to this top dead center, okay, just before reaching to the top dead center, the fuel injector will inject the very high pressurized diesel in it. Okay, very high pressurized diesel in it, around 8 bar से भी ऊपर का pressure होता है उसमें. Okay, so when it will be injected in that air, okay, pressurized air, what will happen automatically? Okay, automatically the ignition will start. Okay, automatically ignition will start because of the compressed fluid. Okay, air be compressed hai, the fuel is also compressed. Okay, so automatically what will happen, as the pressure is very high, it will go beyond its auto ignition temperature. Okay, that means automatically the ignition will start, and what will happen, a huge explosion will carry out over here. And when the huge explosion is carried out over here, what will happen, the piston will get pushed down and the power will be developed over here. Okay, again the burn gases has to be thrown outside, so there will be an exhaust process. That means piston will move upward and burn gases will be thrown through this manifold. Again the piston will move downward, the volume will volume will increases, pressure will decreases, and fresh charge means fresh air will be taken inside here in case of the diesel engine. Did you understood the 4-stroke petrol engine and 4-stroke diesel engine?
Yes, ma'am.
Yes, ma'am.
Okay. Okay.
Yes, ma'am.
Today we are going to see only 4-stroke petrol engine and 4-stroke diesel engine. I'm not at all going in the 2-stroke for now. Okay. So now some of you may get a question that why we are not having the same system for petrol and the diesel, right? So the reason
Yes,
is
ma'am.
that, let's say if you are having the petrol engine, okay, and you will try to use the diesel in it. So what will happen, basically what is going to happen in the petrol engine, air and fuel mixture is already prepared outside the engine. Okay, and for that carburetor is used. Hopefully you have heard about this word carburetor. Yes,
Yes, ma'am.
have you heard?
No.
No.
Okay, maybe seen Rachna, no problem. Okay, whenever you are using a petrol engine, okay, so in that case carburetor is the device which basically helps to prepare a mixture of petrol and the air before sending it into the engine. Okay, so let me show you the diagram once again so you'll understand how basically the carburetor works. No one is going to ask you into detail, but I will simply let you I'll show you so that you will understand basically what is going to happen and why it is different. Okay, hopefully you can see this image. So this is the construction, simple or the basic construction of the carburetor. Okay, so in the carburetor what is going to happen, here is the inlet for the air. Okay, and this is the passage. Okay, and in between that passage you will find that this is a venturi. That means suddenly the cross sectional area is decreased over here. Okay, when the cross section area is decreasing, at that time what will happen, the kinetic energy increases and the pressure will decreases, right? Okay, we have seen that in the nozzle also. Okay, so what is going to happen here, and at this center of, or the throat of this venturi, the pressure will decreases. Okay, here you can see this is the fuel tank. Okay, from where the fuel will be injected through this jet. So a small pipe is actually there which is going to open at this venturi. Okay, when the air is flowing over this, what will happen, at this venturi the pressure will drop down. As the pressure will drop down over here inside this fuel tank, the pressure is atmospheric pressure, and we know very well that any fluid will travel from high pressure to low pressure, right? So what will happen, here is the atmospheric pressure and here the pressure is decreased one, reduced pressure is there, less pressure is there. So what will happen, the fluid will be automatically sucked towards this venturi, and when it is sucked through this small pipe, at the end of this pipe there is again a nozzle is available. When it is passing through the nozzle, what will happen, it will be converted into very fine droplets. Okay, बहुत छोटे छोटे droplets में convert हो जाएंगे. That means it will be very easy to mix up with the air. Okay, and जितना ज़्यादा अच्छा mixing होगा, you will ensure that there will be a complete combustion will be there inside the combustion chamber. Okay, or inside the IC engine. Okay, so that's why the nozzle is also provided. Okay, so what is going to happen here, the air and the fuel, that means petrol, it is going to mix in this carburetor and then it will be sent into the engine. Okay, so this is going to happen basically in the petrol engine. And now let's move back to the previous question. That why we are not using the same system. Let's say we are having the petrol engine, and if we try to use the diesel in it, so what is going to happen? See, diesel is having a very high viscosity. Okay, it is very viscous in nature, and when you will try to pass it through this carburetor, okay, when you will try to pass it through this carburetor, it will be very difficult to convert it into very fine droplets because of its viscosity. And if the droplets are not fine, that means you will not be you can't ensure that there will be a complete or the proper mixing of the air and fuel mixture will be there. Okay, that means at the end in the combustion chamber you will not ensure that there will be a complete combustion takes place. Okay, so what will happen over here? Let's say if you allow that diesel and air mixture to come inside here, diesel droplets are very bigger one. Okay, so when you are allowing the spark plug to spark the to send the spark in this mixture, certain at the certain process certain section or यहाँ पे कुछ जो छोटे छोटे chambers बने हुए हैं. Okay, so in that basically where the droplet is small, only at those places at those places or for that droplet the combustion will start. If the droplet is bigger one, the combustion will not start easily. Okay, it may need very high again temperature. Okay, so what will happen? After initially the combustion will start, but after certain over a period of time what will happen, ये जो combustion process है, okay, it will start delaying. Why? Because of the bigger droplets of the that diesel. Okay, and अगर ये power stroke निकल जाएगा और उसके बाद combustion होगा, then what will happen? There will be a loss of energy. Okay, loss of energy will be there. So that's why it is not suggested to use the diesel in a petrol engine. Okay, now vice versa. Let's do a vice versa. What if you are using the petrol in a diesel engine? Okay, if you now we are taking the air, okay, and instead of the spark plug there will be a injector will be there. Okay, so in that case what you are going to do, you are going to inject a high pressurized petrol inside this chamber. Okay, but now if we see the property of the petrol is having very high auto ignition temperature. Auto ignition temperature means what? When the temperature of that fuel goes beyond or reaches to that temperature and slightly goes beyond that, automatically without any sparking or without any external mean, automatically the combustion will start. Okay, but now here the pressure the auto ignition temperature of the petrol is very high as compared to the diesel. Okay, so due to that what will happen here, automatically the combustion will not start at all. Okay, that means there will not be any power stroke, power process will be there. Okay, so that's why we can't use the petrol in the diesel engine. Did you understood this?
No,
Did you
ma'am.
understood this?
No.
Yes? No? Nothing?
Ma'am,
No, ma'am.
can you tell the summary
I
of
didn't
both
understand the
differences?
petrol in
Only
diesel
differences
engine.
are okay.
थोड़ा.
Okay. See, if we use diesel in a petrol engine, diesel is a viscous in nature. Okay, that means you can't convert it in a fine droplets. Okay, अगर fine droplets है ही नहीं, that means you can't ensure the proper mixing. प्रॉपर मिक्सिंग नहीं है तो क्या होगा, यहाँ पे स्पार्क प्लग सिर्फ एक ही जगह पे स्पार्किंग करने वाला है. यहाँ पे जो कॉर्नर्स में है वहां पे स्पार्किंग करेगा क्या? नहीं करेगा. सो बट व्हाट विल हैपन, जब वो स्पार्क करेगा सिर्फ यहाँ के सामने वाला जो है वही बर्निंग होना स्टार्ट होगा. ओके, लेकिन डीजल के ड्रॉपलेट्स अगर बड़े बड़े हैं, ओके, इफ द ड्रॉपलेट इज बिगर वन, दैट मीन्स द एरिया इज लेस, सरफेस एरिया इज लेस. ओके, क्योंकि एक साथ वो पूरा कंबाइन हो गया है. मल्टीपल ड्रॉपलेट्स अगर लो, ओके, और उसका कंबाइंड आप सरफेस एरिया निकालो तो वो ज्यादा होता है कंपैरेटिवली टू द सिंगल ड्रॉप विच इज अ बिगर वन. ओके, और जितना ज्यादा सरफेस एरिया होगा उतना जल्दी वो क्या करेगा, फायर कैच करेगा. ओके, अगर डीजल अगर आप यूज कर रहे हो, एज आई सेड डीजल इज अ विस्कस इन नेचर, सो ड्रॉपलेट्स विल बी द बिगर वन. ओके, दैट मींस वेरी डिफिकल्ट टू कैच द फायर. ओके, शुरुआत में कैच करेगा भी, बट कुछ पार्ट जो रहेगा वो क्या होगा,
मैम
अनबर्न रहेगा.
ये समझ में नहीं आ रहा है. ड्रॉपलेट्स बिगर वन मतलब वो तो पहले से लिक्विड फॉर्म में होता है, तो ड्रॉपलेट्स बिगर वन मतलब क्या?
हाँ मैम।
Liquid form is
Carbonate
different,
में
beta. See, when you are passing the water through the hose, okay, जैसे ही आप उसको pinch करते हो, okay, उसको अगर आप carefully observe करोगे तो क्या होगा, वो छोटे छोटे droplets में बाहर आता है,
ओके मैम, हाँ समझा समझा।
circular droplets,
हाँ मैम।
okay, drops की तरह बाहर आता है, okay, जितना छोटा छोटा ड्रॉपलेट रहेगा उतना उसको अगर आप लेट से 2 ड्रॉपलेट्स लेते हो छोटे छोटे साइज के, उसका सरफेस एरिया ज्यादा रहेगा, और उसी को अगर दोनों ड्रॉप्स को हम लोग अगर कंबाइन करते हो, ओके, तो उसका अगर आप सरफेस एरिया गिनते हो, वो जो स्पेरिकल फॉर्म बनेगा उसका सरफेस एरिया अगर गिनते हो, ओके, तो वो कम आएगा।
हाँ मैम,
ओके,
समझा
सो
समझा।
सरफेस एरिया आपको ज्यादा चाहिए सो दैट यू कैन एंश्योर द कंप्लीट कंबशन विल टेक्स प्लेस। डीजल विस्कस है, सो ड्रॉपलेट्स की साइज कम रहे, सॉरी ज्यादा रहेगी, क्योंकि वो स्प्लिट अप ही नहीं होगा जल्दी। आप पानी लो और ऑयल लो, ओके, पानी जल्दी से स्प्लिट अप हो जाता है बिकॉज इट्स विस्कोसिटी इज लेस। अगर ऑयल लोगे, यू इट इज वेरी डिफिकल्ट टू कन्वर्ट इट इनटू द वेरी स्मॉल ड्रॉपलेट्स। सेम होज से पास करो, you will find that oil will have bigger droplets and water will have smaller droplet. Okay, so that is what the difference is there in the diesel and the petrol is. Okay, so उसी वजह से हम लोग डीजल यूज नहीं कर सकते इन द पेट्रोल इंजन। ओके, एंड अगर
Yes, ma'am.
डीजल इंजन में पेट्रोल यूज करते हो तो क्या होगा, यहाँ पे ऑटो इग्निशन टेम्परेचर वो रीच ही नहीं करेगा।
हाँ,
ओके,
क्योंकि वो मतलब
यस, क्योंकि
बड़े
पेट्रोल
ड्रॉपलेट्स
का
होते हैं
ऑटो
डीजल
इग्निशन
में।
टेम्परेचर बहुत हाई है, और हम लोग स्पार्किंग तो प्रोवाइड नहीं कर रहे हैं यहाँ पे, तो वो खुद से बर्न ही नहीं होगा। So how your power will be developed over there? So that's why we can't use the petrol in a diesel engine or diesel in a petrol engine. But still, research has gone forward. Okay, and there is another engine that is a GDI, that means gasoline direct injection system. Okay, उसमें basically जो है जैसे आप फ्यूल इंजेक्ट कर रहे हो यहाँ पर डीजल इंजन में, उसी तरह से उसमें भी पेट्रोल इंजेक्ट किया जाता है। वर्किंग इज क्वाइट सिमिलर टू द डीजल इंजन, ओके, बट द डिजाइन इज डिफरेंट। थोड़ा डिजाइन पैरामीटर्स चेंज हो जाते हैं, प्रेशर जो है वो हायर प्रेशर पे वर्क करता है। ओके, सो इट इज क्वाइट एडवांस वन। आई विल नॉट, मैं नहीं जाऊंगी उसमें अभी के लिए, अदरवाइज यू विल गेट कंफ्यूज फ्रॉम दिस पार्ट। ओके, बट आपको अगर पढ़ना है, यू कैन गो थ्रू द डिफरेंट वीडियोस फ्रॉम द यूट्यूब आल्सो, और you can learn it from the Wikipedia also. Okay, or I will try to share you videos related to that, so whoever is interested, they can watch through that. Okay, so hopefully you have understood till now that what is the difference between 4-stroke petrol engine and what is the difference between the petrol engine and diesel engine. Yes,
Yes, ma'am.
यस मैम।
Yes
okay,
मैम।
ठीक है।
मैम
So let's,
एक
yes,
मैम 1 सेकंड में 4 स्ट्रोक इंजन कितने साइकिल कंप्लीट करता है, मतलब रेंज क्या होगी उसकी?
सेकंड में इट एक्चुअली डिफरेंट फॉर डिफरेंट इंजिन्स। जो भी मैन्युफैक्चरर होता है ना, वो उसके हिसाब से होता है, और बेसिकली एज वेल एज आप जो एक्सेलरेशन देते हो, ओके, जो स्पीड बढ़ाते हो ना आप, तो उस हिसाब से भी साइकिल का टाइम चेंज होता है। इट इज नॉट सेम एवरी टाइम, इट चेंजेस। आप एक्सेलरेट करते हो मतलब क्या कर रहे हो कि वो जो क्रैंकशाफ्ट है वो जल्दी जल्दी घूमना चाहिए। वो कब जल्दी जल्दी घूमेगा, जब साइकिल आपकी फास्ट 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 होगी। आर यू गेटिंग दिस?
यस मैम।
ओके, जब स्पीड स्लो डाउन करोगे तो साइकिल भी स्लो डाउन हो जाएगी। ओके, सो ऐसा कुछ नहीं है कि 1 सेकंड में मतलब हमेशा सेम ही रहेगा। इट विल चेंज अकॉर्डिंग टू व्हाट हाउ यू आर एक्सेलरेटिंग, किस तरह से आप एक्सेलरेट कर रहे हो, किस तरह से आप रिक्वायरमेंट दे रहे हो उस इंजन को। ओके, okay, now let's move back to the classification of the IC engine. Okay, I think we still have 10 minutes. Okay, so we can cover this part. So now classification based on the number of stroke of the per cycle, it is classified as 4-stroke and 2-stroke. 4-stroke we have already seen, 2-stroke we are going to see in the next class. Okay, next one is the based on the thermodynamic cycle. When these 4 processes are carrying out, okay, at that time certain thermodynamic cycle is going to carried out in that. You have studied about the constant volume process, called constant pressure process, then constant thermal process, isothermal process, isobaric process, isochoric process, adiabatic process. Yes, ये पढ़े ना?
Yes.
Okay,
यस मैम।
they all are the thermodynamic processes. Okay, and when they hold this whole cycle, that is suction, compression, power stroke, and exhaust, if they are following certain cycle, okay, by using these processes, thermodynamic processes, okay, then it is classified according to this these three types. Okay, first one is a Otto cycle, diesel cycle, then dual cycle. Otto cycle means what? Petrol cycle, okay, in which the combustion process is carried out at a constant volume. Okay, while in a diesel cycle, combustion is carried out at a constant pressure. Okay, and in a dual cycle, partially it is at constant volume and partially it is at a constant pressure. Okay, so based on it, basically the engine are classified whether it is following Otto cycle, diesel cycle, or dual cycle. Okay, next one is based on a number of cylinder, how many cylinders are available in that particular engine. अगर एक ही सिलेंडर है तो सिंगल सिलेंडर, मल्टीपल सिलेंडर्स है तो मल्टी सिलेंडर. फॉर एग्जांपल अगर आप लोग टू व्हीलर्स में जाते हो, मोस्टली दे आर हैविंग द सिंगल सिलेंडर्स. ओके, अगर फोर व्हीलर्स में जाते हो तो 3 सिलेंडर्स होते हैं या फिर कभी कभी 4 सिलेंडर्स भी होते हैं. ओके, सो इट इज दे आर द मल्टी सिलेंडर्स. सो बेस्ड ऑन हाउ मेनी सिलेंडर्स आर अवेलेबल इट इज क्लासिफाइड. ओके, सो हियर यू कैन सी दिस इज द मल्टी सिलेंडर. 2 सिलेंडर्स आप देख सकते हो. ओके, ये भी मल्टी सिलेंडर है, 3 सिलेंडर्स है अलग अलग. ओके, again it is classified based on the arrangement of the cylinder. Cylinder किस तरह से arrange किया हुआ है. First one is a inline cylinder. So inline cylinder, this is a animation for the inline cylinder. That means all the cylinders are arranged in a single line. Okay, so that's why it is a inline cylinder. This is the V type cylinder. Okay, दो cylinder V arrangement में है. Okay, so ये 3 cylinder है, 3 इस side है, 3 इस side है. So total 6 cylinders are there and they are arranged in a V manner. That's why V cylinder. Okay, V engine. It is known as a V engine. Here you can see these are radially arranged. Okay, radius wise arranged किया हुआ है. So this is the radial engine. Okay. Then this is the opposite cylinder engine. Cylinder कैसे opposite direction में है. 2 cylinders are there, but they are oppositely arranged. So this is opposed cylinder engine. Okay. अभी आप इसमें देख सकते हो, सिर्फ इतना observe करो. This one. Okay. Piston are oppositely arranged. Okay. Pistons are oppositely arranged. So that's why it is a opposed engine, opposed piston engine. Okay. Okay. So this is what basically based on the arrangement of the cylinder, IC engines are classified. Next one is based on the ignition system. Okay. Now we have seen 2 types of ignition. First one by using the spark plug. Second one is by using the compression. Okay. That means in a diesel engine. Okay. So SI engine means spark ignition engine. That means spark plug is required over there, like in a petrol engine. Okay. CI engine means compression ignition engine. That means just due to the compression, that means just by increasing the pressure, automatically the ignition is starting. That means like in a diesel engine, that is a CI engine. Okay. So all petrol engine are a SI engine, all diesel engines are a CI engine. The next one is based on the cooling system. Okay. Every engine needs the cooling. Okay. Because heat is going to lost. Okay, through the surrounding, through these materials. Okay, because the heat is going to conduct basically. जो भी combustion होने वाला है उसके बाद heat जो है surrounding parts में conduct होने वाला है. So definitely heat is going to loss in that case. Okay, and if we are not allowing the heat to be carried out into the atmosphere, those parts will accumulate that heat and they may get damaged over a period of time. So we have to cool the system, cool the engine. So if it is air cooled, if the air is used for cooling purpose, then it is a air cooled. If liquid is used, that means coolant is used, then it is a liquid cooled. Liquid cooled we have seen already, right? Air cooled, just a minute, I will show you the air cooled. Okay, hopefully you can see this image. So this is the engine of the bike and you can see this small linings are there on the top of the engine. Basically these are known as the fins. Okay, you can see here also these are known as the fins. What these are doing, they are helping you to increase the surface area. Okay, we have seen the formula for conduction, that is the heat transfer rate is directly proportional to area, right? We have seen this from the Fourier's law. So if the area is more, heat transfer rate is going to be more. Okay, so you can see here, or even from the convection also, if the area is more, heat transfer rate is more. So let's say ये fins है ही नहीं यहाँ पे, it is completely flat. So what will happen? The area is less, so the heat transfer rate is less. So to increase the heat transfer rate, that means air has to be more in a contact with this engine. So for that purpose, these fins are used. Okay. So what is going to happen in the vehicle, in this two-wheeler? The air is going to flow over this fins and it will carry the heat with it. And likewise, the heat, that engine is getting cooled. So that's why it is known as an air-cooled engine. While in case of, let's say, trucks, okay, or your four-wheelers, they are having the compact engines. Okay, engine is completely placed inside the casing. Okay, पूरा जो cover है कार का, उसके अंदर में होता है. So how the air is going to flow over it? Okay, so that's why it is cooled by a liquid. Coolant is sent in through that jacket, which I have shown it to you in this slide. Okay, these jackets, the coolant will flow through this jacket. Okay, so that's why it is known as a liquid cool, and that liquid is further cooled in the radiator. Okay, by using the air. So this is the next classification, that is based on the cooling system. Okay. Then further, based on what type of fuel is used. If petrol is used, it is a petrol engine. Diesel is used, diesel engine. Gas is used, gas engine. Biofuel is used or biodiesel is used, it is a biodiesel engine or biofuel engine. Okay. Then next one, based on the fuel supply, how the fuel is supplied to the engine. If you are using the carburetor, that means like in your petrol engine, then it is a carburetor engine. Okay. If you are using a direct injection, okay, direct injection is there, or injector is provided, then it is known as a solid injector. Okay. Then next one is a based on the lubrication. What type of lubrication is there? Now engine is having multiple moving parts. Okay, बहुत सारे moving parts है उसमें. So definitely lubrication will be required, क्योंकि otherwise friction will take place and there will be a wear and tear of the parts.
lubrication क्या होता है?
Lubrication means what? Basically, see, जहाँ भी motion होता है, okay, at those places, the friction will be there, right? If the friction is there, that means heat is going to produce at those places. Simply आप आपका हाथ लो, दो हाथ लो, दोनों हाथ को rub करो. Okay, as there is a motion, what will happen after a certain period of time? Just due to that friction, a heat will be developed. Okay, और
उसे lubrication कहते हैं.
Yes, नहीं, उसे lubrication नहीं कहते. उसे फ्रिक्शन कहते हैं.
lubrication.
So जो मोशन है, ओके, वहां पर कुछ देर के बाद जब हीट वहां पे स्टार्ट हो जाएगी, फ्रिक्शन बहुत ज्यादा होगा, तो वियर एंड टियर होना स्टार्ट हो जाएगा. ओके, जब मेटल पार्ट्स एक दूसरे के साथ घिसे जाएंगे, तो वहां पर क्या होगा? वियर एंड टियर स्टार्ट होने लगेगा, खराब होने लगेगी. ओके, और क्या होगा? खराब होने की वजह से क्या होगा? वहां पे फ्रिक्शन और भी ज्यादा डेवलप होने लगेगा. ओके, हीट कैरिड आउट ही नहीं होगा बाहर में. सो टू अवॉइड इट, लुब्रिकेशन इज डन, दैट मींस ऑयलिंग इज डन. आप लोगों ने साइकिल चलाई है?
हाँ मैम, हाँ समझा.
राइट, साइकिल में जो चेन होती है, वहां पर क्या है? मोशन है. सो यू टाइमली यू हैव टू सप्लाई ऑयल टू दैट. ऑयलिंग हैज टू बी डन. ओके, सो ऑयलिंग कर रहे हो मतलब क्या कर रहे हो आप? लुब्रिकेशन वहां पर प्रोवाइड कर रहे हो. आर यू गेटिंग दिस?
Yes, ma'am.
Okay, so that is what is the lubrication is. Now lubrication में भी अलग-अलग types है, 3 types है: wet sump, dry sump and mist sump. Now wet sump means what? See, this is the engine. Okay, ये जो आपका क्रैंक है, क्रैंक के नीचे एक स्पून की तरह लगाया हुआ होता है, बेसिकली एक स्पून की तरह लगाया होता है, और नीचे जो है ऑयल का संप होता है, ऑयल का एक टैंक की तरह होता है. ओके, सो व्हाट दैट स्पून विल डू, जैसे ये रोटेट होगा, ओके, जैसे ही आपका क्रैंकशाफ्ट रोटेट होगा, व्हाट दैट स्पून विल डू, इट विल टेक द ऑयल फ्रॉम इट and splash it over this. Okay, so when it is going to splash, automatically what will happen, that lubrication will be provided or it will be supplied, that oil will be supplied to this moving part. हर जगह पे वो क्या करेगा? splashing करेगा. Okay, that means whole time the engine is going to be wet. That's why it is known as a wet sump lubrication. Okay, लास्ट है, 5 मिनट में खत्म करती हूँ. ड्राई संप में क्या है? अभी वेट संप में क्या हो रहा है? जो दूर के जो पार्ट्स है, the parts which are away from this spoon, this may happen that at those places lubrication may not take place, okay, or it may not be proper. So in that case, instead of this spoon, what is done, a small tubings are provided at those places directly where the lubrication is needed. So that is known as a dry sump. And mixed sump it is a mixture of this, okay. जो दूर के प्लेसेस है वहां पे ट्यूबिंग्स प्रोवाइड किए जाते हैं, पास के प्लेसेस में स्प्लैशिंग की जाती है, ओके. सो दैट इज व्हाट इज द मिक्स्ड सम्प, ओके.
Yes, ma'am.
ठीक है. So this is what is the classification of the IC engine, okay. Now in the next class we will see the two-stroke engine, ठीक है. So I think we should
Yes, ma'am.
stop here for today. Just let me know आपको इसमें ERP में ऑप्शन दिख रहा है या नहीं. 2 मिनट रुको, मैं ऑप्शन को टर्न ऑन करती हूँ, फिर मुझे बताना.
मॅम माझा एका प्रॅक्टिकलला ऍबसेंटी लागली होती फक्त.
मी मोस्टली ज्यांनी मला सांगितलंय मी त्यांची लावली आहे, पण आता ह्याच्या पुढे मी लावणार नाही. 14 तारखेनंतरचं ज्यांचं कोणाचं असेल त्यांचं मी लावणार नाहीये, कारण मी
नाही नाही आधीच
प्रत्येकाची
आधीच.
आधीच असेल तर ठीक आहे, मला सांगा, व्हॉट्सअप करा मला, ठीक है.
ओके मैम, ओके.
लेट मी स्टॉप द रिकॉर्डिंग, मुझे कट करना पड़ेगा आज, ओके.